So over to you, John. You can continue with the hands-on session.
Okay, ma'am. So everyone, I'll be pasting the link to our spoken tutorial for creating the 3D geometry, 3D mesh geometry. So what we'll be doing is we'll be following, I think it is tutorial number 6, 7, and 8. I have just shared the link. So first one is the spoken tutorial link. Second one is the YouTube link. If the video is not working, watch the YouTube link. But for all the material that you will need, like case files and everything, you will have to use this link, the spoken tutorial link. Okay. So we have to do tutorial 6, 7, and 8 today. So in that, what we will be covering is first how to mesh the geometry, that is how to mesh the pipe geometry. Second thing will be how to set up the case, and third thing will be how to visualize, as sir had said. What are the different visualization techniques that we had? A simple overview of that will be done in these 3 tutorials. So y'all can go ahead and start. I myself will also be showcasing, or I will be showing how it is done. So those who are familiar with OpenFOAM a little bit, y'all can go ahead and start with the tutorial. You don't need to wait for me to do it, and you can go ahead and do. So do tutorial 6, 7, and 8. Okay, I'll share my screen. Yeah. So first thing that you need to do is first start your Ubuntu terminal, right? So go to start and go to search and start your Ubuntu terminal. Wait for it; it will load. Now to go to your run directory, you need to type run. You can either type cd $foam run or you can type small run. A small run is a shortcut to go to that. So you type small run and press enter. It goes to your run directory. Now what we are doing is we are copying the tutorial case cavity into the current folder. So to do that, today I'll be showing you all terminal based because I think you've understood now where the file structure is. So we can quickly copy, we'll do cp. So we have shared a list of commands also with you yesterday. So you should be able to understand now. So cp -r means I'm trying to copy a folder from my home tutorials. And inside foam tutorial, it is in the incompressible folder. So incompressible, and in the icofoam folder, and inside that cavity, and inside that there is one more cavity folder. So this you have to copy. So this is the path. So what I've written, this is the path to where the test case is. Right? After that, I need to copy it to the current directory. If I just do dot, it will copy the cavity folder as it is. But I'm going to write pipe over here. That means it is going to copy cavity and it will be named as pipe for me. Okay. So remember, there's a space after cavity and pipe. So this is my destination. So once I do that, I see it is copied. Now if I do ls, I should have a pipe. If you see over here, I have a pipe case already. So it has copied the cavity into the pipe case. Now I need to go to that specific folder. Okay. So I will do cd pipe. Okay. Now in this, if I see, I have 0, I have constant, and I have system. Now, as I've shared yesterday, if we are trying to do the block mesh, am I audible? Okay. If we are trying to do the block mesh, then we'll be changing certain things, right? We'll be renaming the patches, walls, and the boundary conditions we have not yet defined. So at present, we do not need the 0 folder. So what we'll be doing is we'll be renaming it. To rename, I'll type the command mv. I'll rename 0 to 0.orig. So this command will rename 0 folder to 0.orig. Now, if I see this, my 0 folder is renamed to 0.orig. So even if I have not defined anything in the 0 folder, it will not create any problem while I am meshing. Now I need to edit the block mesh dict. So I will open it in gedit. So gedit and my blockmeshdict is in the system folder. Okay, so I have to give the path to the file. So I'll give system and then the name of the file, that is blockmeshdict. So it opens blockmeshdict in my gedit. Now, if you see, this is the cavity case. Now, one thing is you can start writing all of those blocks, how it is defined, but to save time, we have already given all those things in in the case files. So you have to go to the spoken tutorials where we have written, right, the link that I've shared to you. Go over there, and in the code file section, if you see, there is a text file in which the blockmeshdict is given. So if you click on it, that text file will open. Now go to where it has opened, open that in the folder. Okay, so this is that file, extract it. Once you extract it, open it, you see there will be a text file. If I open the text file, it has the whole blockmeshdict written for you. So copy the whole thing. Okay, I'll wait for a while so that everybody is up to pace. Now, this is my gedit. I have copied the contents. I'll paste it over here. So if you see in my in the text file, we have the contents all the way from convert to meters. So we have copied from convert to meters to everything else. So here from convert to meters, that is in my blockmeshdict file, from convert to meters all the way up to the final line, I don't need all these entries. So I'll be deleting them. And I will paste the new text that has been copied. Okay. So now I'll wait for a while. You all try to do this. If you have any error, you can write in the chat. Our team is there. They will guide you. If it is a simple error, I can also tell you quickly. So now you will have all those vertices, blocks, edges, and all the boundaries defined, like inlet, outlet, and walls defined. I hope everybody is able to do till here. Okay. After this, what you need to do is save this file.
How to get this pipe file? How to go to the pipe file?
How to go to
pipe file?
Okay. So if you see what we have done, first step is we went to a run directory, right? In that, I have copied the case called as cavity. And while copying, I have renamed it to pipe. So pipe is nothing but cavity that is copied from the tutorial case to pipe. So that is where your pipe is. And if you check after I do that, if I run the command ls, there is a pipe that has come into my run directory. And that is nothing but a copy of cavity. And in that, we have done certain things, right? In that, we have gone and renamed the 0 folder to 0.orig. And now we are editing the blockmeshdict. To edit the blockmeshdict, you need to get the new blockmeshdict file. So that we have given to you in the code file section on our website over here, spoken tutorial website. The link that I have shared to you, if you scroll down, there is a section called as code files. There is a pipe.txt file. If you click on it, it will download it. You need to extract it. And once you do that, copy the contents of the pipe and paste it into your blockmeshdict after deleting the old contents from, I think, line 15 or 16. Don't delete the top headers, whatever this is written, like object and everything. So this is needed. This is a file structure. Please don't delete that. You have to delete right from convert to meters all the way up to the last line. And then paste the new text. After this is done, press save and then close this blockmeshdict file. Now our blockmeshdict is ready. Now we can just directly do the blockmesh command. So we are in the pipe. I can run the blockmesh command.
Hello, John, sir.
Yes.
Sir, I followed all the instructions given in the spoken tutorial, but as I type the gedit command, the file is not opening.
It might have opened in the background. Just see.
Oh, sorry. I mean, the file is opening, but it is blank.
It is blank. So you might have not
Yes.
given the correct path. Please just check if the path is correct. Sometimes if you don't give the correct path, this happens.
Okay.
While doing that gedit command, right? Make sure you're giving the first see in which folder you are in. Either you are in 5 or you are in your run directory, where you are.
I'm in my run directory.
Then you have to go to and what is the this command that you have given?
Gedit space system / block mesh dict.
See, because you are in a run directory, in the run directory, you are telling it to search for system and block mesh dict.
Okay.
You need to be in your pipe directory. So in run, first do cd pipe. Type this command, cd space pipe. Okay, it will take you to pipe and then run that gedit command. Did you understand what you're trying to do?
Yes,
you're trying to ask it to search for system folder in the run directory, which is
Yes, sir.
that's
It
why
worked.
it worked. Okay.
Thank you so much, sir.
Okay. Yeah. So I hope everybody is able to do till here. Our team will help you. So now what we are seeing is the mesh is done and we have created some 3 patches with some number of cells and points. So 3 patches that are created are inlet, outlet and wall. So if people are still stuck, I will tell you what I've done again. I opened my Ubuntu terminal. Then I typed run. When I type run, it takes me to my run folder, that is run directory. Alternative to this is you can type cd dollar foam run, cd space dollar slash foam run, sorry, cd space dollar foam run. That is also a command that takes you to the run directory. This is a shortcut. You just type run, it takes you to the run directory. Then you have to copy the cavity case into your run directory. But while copying, you have to rename it as pipe. So the command is cp-r. This is the location for your tutorial case, and this is the new file name, that is pipe. So it copies the contents of cavity into the folder named pipe. After doing that, if I do ls, it shows in my run directory, I have a folder named pipe. That means I have successfully copied it. Then I enter into that folder by typing cd pipe. Now, if I see inside that folder to see the contents, I'll do ls. It will list the contents. So I have 0, constant and system folder. As I previously stated, if you have not, when we are only doing the block mesh, we have not yet decided on the boundary conditions, the patches, anything. So 0 folder is not needed. And if we keep it, the paraview may give us a problem. So what we do is we first rename the folder 0 to 0.orig by typing the command mv, name of the file and the new name of the file. So I am renaming 0 to 0.orig by this command. Now if I do ls, you see 0 constant and system has changed to 0.orig constant and system. After that, we are now ready to edit the blockmeshdict file. So we open the blockmeshdict file using the gedit text editor. So somebody had a problem. So they were in the run directory. So if you are in the run directory, then in gedit, you have to type first pipe, then / then system, then blockmeshdict. So you are giving a, or the other thing is go into the pipe directory by doing cd pipe and then typing this command. After doing that, what I have done is in my blockmeshdict, whatever was the old vertices, right? I've deleted those old data right from convert to meters all the way up to the final line. Then I have downloaded the pipe, this text file from our spoken tutorial website in the code file section. This is it. Okay. And after downloading that, I have extracted it, copied its contents, and pasted it into our blockmeshdict file. After doing that, I have saved that blockmeshdict file, and then I have just run the command blockmesh. So it meshes the file. So you need to be ready with this to do the next steps. So I hope everybody has done this. If you have any query, you can post in the chat. Our team will help you. So just so that to view the mesh that we have done it correctly, we can do parafoam. So after blockmesh is done, I'm running the parafoam command. Now if I click on apply, you see my geometry is there. Okay. If I want to see the mesh, I will over here in my controls over here, instead of surface, I will select surface with edges. So this is our mesh. Sorry, I'm zooming too much. Okay, and this is our mesh in the Y direction. Oh, sorry, Z direction. So our mesh is ready. I hope everybody has done till here. We are getting that. So we have different patches. If you see over here, we have an inlet patch, an internal mesh, outlet patch, and a patch named wall. I can uncheck that, maybe show you just inlet. So that is my inlet, outlet, inlet patch, outlet patch, and the patch named wall. So this is a geometry. I hope everybody has done till here. This was the first tutorial, part 1, where we are running the block mesh. So what is the status?
Hello.
Yes.
Sir, how can we change the appearance of the geometry like with the color, like inlet, outlet, and wall color?
Okay, so here by default, inlet, outlet, and walls are taking different colors. You see by this block, VTK block. Okay, so here by default, they are taking different colors. If you have to color them differently, I think you will have to explore this. I have not explored that to see how to color them differently. I think here there is some edit features, VTK block colors edit. So you can go over there and maybe edit specific blocks if that is your requirement. Okay, but here if you see right now, we have different colors for different blocks. So my inlet, outlet, and my walls, they are already colored in a different scheme. So that scheme will already be there. They will be colored differently. So you have a red color, green color, and a white color. Okay. Is everybody able to do till here?
Yes,
Can
sir,
you
done.
explain this one slightly para view part? Exactly, I am not able to understand how you are handling that one. Can you after opening the para view?
Yeah, so no, you don't have to do anything. What I'm doing is I'm just showing you the mesh. Okay. So once you open ParaView, if you want to see the mesh, okay, I'll do that again. So now I'm in the terminal. I'm just typing a paraform command. That opens the ParaView. Now if I apply, I will get the geometry. So this is my geometry, okay, where I have an inlet, I have an outlet, and I have the walls. Now, if you see, I'm just rotating it by pressing my left arrow and moving. If I want to see the mesh, I'm selecting here. Let me bring it down so that it is visible. I am selecting surface with edges. So if once I do that, along with surface, it also shows edges. That is how the mesh will look like. This is some glitch in ParaView. Okay, I can do.
Why the colors with different white and this?
So see, it should come like this. That is some glitch. I think in ParaView it is coming. So you see, it will all red now. Now the red is one color. So inlet may be red, outlet. So all the different patches that you have, they will be colored differently to identify them. Okay, and there is no particular color scheme that inlet is this, so that is not there. So now see, we have this. This is our mesh.
From here, we cannot know that block. We have 5 blocks, meaning block 1, block 2.
Okay, you can see that. To do that, I'll close this. While starting paraform, you have to mention paraform and then dash block. So this is the command. So it opens paraform and you will be able to view the blocks. So if you see over here, block 0, 1, 2, 3, 4 has come on the left selection. If I click apply, it will show the blocks and with the numbering. So you have block 0, block 1, block 2, block 3, and block 4. Now if you want, I will uncheck everything and check only block 0. So this is your 0th block. Okay, if I check one, this is my first block. Similarly, block number 2, block number 3, and block number 4. If you want block, what are the different blocks? You can access them by typing in while starting Parafoam. You have to give one more keyword dash block. So it shows this view where you know what are the different blocks. So if you have made some mistake and it is not showing properly, then you can do this view to see where you have made a mistake while defining some points or something. Okay.
Hello.
Yes.
Hello.
Yes.
So if a Parafoam command is not working, I am using explorer.exe command. So how can I use this command?
First you need to okay. You have to do result.foam, right?
Yes, sir.
Okay, this have you explored? No, he's block. How will you see block? Then I think block is kind of difficult with that.
Okay.
Okay.
Okay,
Because
sir.
with this what happens is it directly opens ParaView with the block.
Okay, sir.
We'll have to explore that. I don't know. We have not tried that.
Okay, no problem.
Generally, but if you do run this command parafoam dash block, it opens with the block. This generally you don't need only if you're facing some problem. You know your blocks are not coming out correctly. You want to know if you have not given some points, then maybe this can be used. But other than that, in fact, that can also be seen in your normal parafoam also if there is some error in the points. So I hope everybody has done till here. So now once we do this, then we need to switch over to our next tutorial. I'll share the details of the next tutorial. Just give me one moment.
We are not solving this one.
Yeah, we will be solving this only. But see, in spoken tutorials, what we do, we create tutorials in parts so that people can watch them. If the tutorial is too lengthy, then if somebody has a bandwidth problem, all those things. So keeping all those things in mind, this tutorial is split into 3 parts. Okay, one is only about meshing, where we talk in detail about meshing. So if you would have seen that video, they'll explain what are the different blocks and everything, which sir has already explained. So I don't think so we need to go through that. Then the next is the case setup that we will be seeing now. So the case setup and running is what we will be doing. Once we do that, then the next part will be to do the ParaView, right, and to visualize it. Yeah. So if you see, I have pasted 2 links. One was for our case setup, right? That is there in our our FOSSEE website. The next I have shared with the YouTube link. So you can use both of them to do the next steps. But to do the next step, you need to have this block mesh file ready. So if you have any problem, you can post in the chat. Our team is there. They will help you.
Sir,
Yes,
I followed the instructions given in the tutorial. In that, they have told that to open the P file in the gedit. So I'm not getting what command we have to put to open that P file.
Yeah. Can you please repeat? I couldn't hear you.
In the tutorial, they have said to open the P file in the text editor.
Yes.
So what command will you have to put?
So to open the P file, how do you open, like?
Usually we use gedit.
Correct.
After that.
And where is your P file?
So P file, I'm confused. What is it? It is the
P is the pressure.
Pressure.
These are boundary condition files, right? P file,
Yes.
U file, all these are boundary condition files. They are in your 0 folder. I will demonstrate that. You can wait for a while.
Okay, sir.
Okay, I will demonstrate that. Just hold on. I was just waiting for people to come to place, so that, because if you miss, so I will share my screen and then we can start that. Just give me a moment. Now, if you go through the video, in the video they will be talking about what is the exact case setup. So we are solving it for an RE of 250. So we have talked about what is the problem setup, what is the length, what is the inlet velocity, what is the diameter. Now, and what are the various properties. So you can go through this so that you understand what is happening. Okay. Then Based on the RE, the flow is laminar. So we have also calculated what is known as the entrance length. That is the length needed for the flow to develop fully. So our entrance length is only 0.15 and we have given a length of 0.3. So we would expect that the profile at the outlet to be parabolic. And we are using icofoam solver to solve the case. And what are the various boundary conditions? At inlet, we are giving 0 gradient. This is for pressure. At outlet, we are giving 0 Pascal. That means at the outlet is gauge pressure is 0. Okay. It is discharging to ambient. We are thinking like that. Okay. At the wall, it is 0 gradient. And for velocity, at the inlet velocity, we have a velocity of 0.025. At the outlet, it will be 0 gradient. And for the walls, no slip boundary condition. So this is how the case has been set up. Now, how will you run it? I'll show you how to run it. So now we are already in the pipe folder. So everything is there. Here, what the tutorial is saying is how you can view the file, right? So you can type to open the P file. You need to type. First of all, if I do ls, right? My 0 folder is named as 0.orig. This was so that it does not create any problem while meshing. Now my meshing is done. So the next thing for me to do is to go back and rename my 0.orig folder to 0 folder. So we are doing the opposite now. So we are, by this step, what we are trying to do, rename the 0.orig folder to 0 folder, because this will be needed for a simulation. So after I run this command, if you see, if I type ls, my 0 has been renamed to, 0.orig has been renamed to 0. That is the first step. Now, what I should do is, I should see what are the contents of my P file. So now, important to know is, I am in my pipe directory. Okay, if you are not in your pipe directory, this command also would not have worked for you. So first thing would have been to go into the pipe directory. But I hope that because you have run all this block mesh and parafoam command, you are already in your pipe directory. So now I need to type the command gedit space. Okay, before that I will, so that it is much easier, I will go to my 0 folder. I will do cd space 0. Or let me try 3, right? 3 command will also work, right? So if I try, huh? Okay, I'll just see if 3 works. Okay, no, let it be. I will do cd 0. Just forget about the tree. That works in Linux. So if you see,
First command to be typed now.
Hello.
Hello. What is the first command?
So first command, have you done the block mesh everything? If you have done your block mesh, the first thing that you need to do is rename your 0.orig folder back to 0 folder, because now we have to do the case setup. Once that is done, then what you do is go into the 0 folder by typing cd 0. Okay, now if you do ls, there are 2 files over here, u file and p file. These are the boundary and initial condition files that you need, right? So your boundary conditions and initial conditions are specified in this 0 folder. Now, if I want to open the P file, I'll type gedit and then P. I don't need to write what you can say 0 comma P, because I'm already in the 0 folder. If you see, I'm already in the 0 folder. That's why I don't need to write that. If you're not in your 0 folder, then you need to write 0/P. Okay, to show you what are the contents of 0, I have done that. Okay, or I can show it to you from your this over here. I'm going to home, where the exact file structure is, or I will give you another shortcut. So in the pipe directory, I will just type explorer. I think yesterday I had shown you this, explorer.exe and space and then dot. So it opens the current working directory in your file browser. So this is your file browser. So it is showing what are the contents of, sorry. It is showing me the contents of the pipe folder. So in my pipe folder, I have folder named 0, constant and system. In 0, I have files named P and U. These are my initial and boundary conditions files. We'll be opening them one by one. So if you can open it from this, or I'm showing you how to open. So now I've come back to my file directory. So if I have to open, then my command will be gedit space 0. In 0 folder, I need to open P. So 0/P. When I run this, the P file will open. So if you see, this is the P file. But this P file is for the previous case because we have copied if you remember, we have copied the cavity case. So it will have all the, what you can say, boundary conditions needed for the cavity case. So we need to change this. Okay. I can manually change it, but for ease, so that we can do it quickly, we have already provided you with the setup file. So go to the spoken tutorial over here. So this is your simulating Hagen poesy flow. So if you can go down, there is code file. So there is a code file for pressure.txt, right? .txt file for pressure. So if you click on that, it will open the P file. The P file is getting downloaded. I'll open where it is in my folder. I'll right click and extract it. Okay, inside this, if you see, if I open it, I have the P file, U file. Sorry, I have the pressure, velocity, and control dict file. Now I need the contents of the pressure file. So I'm opening the pressure in the text editor. So if you see, all the way from internal field, everything has been written out and given to you. So copy that. Okay. And then after copying, you have to go to your text editor, which was already there. So I have copied everything from internal field. So I have to delete everything from internal field. Please don't delete the dimensions. If you delete the dimensions, then it will give you problem. So right from, okay, I think I'm going a little fast. Some of you are suggesting that I go slow. So I'll just hold on. I'll repeat this, whatever I've done, so that you understand. So we have now opened our if you see, I have now opened my P file with a gedit text editor. That is this. All the initial and boundary conditions are that of the previous case. And the previous case was the cavity case that we copied. So I need to change all of this. So I can manually change it, but we have already written it out for you, and that is available in your code files section. So you go to the spoken tutorial link that we have given to you, scroll down and click on the code files. So if you click on the code files will be downloaded in a downloads folder. Now when you open the downloads folder, you have to extract it. Once you extract it, 3 files are there in that: pressure, velocity, and control. I hope everybody has done till here. Now open the pressure file. Now in the pressure file, if you see, we have contents all the way from internal field till the end. So copy the whole thing by pressing Ctrl A, Ctrl C. Now if you go to your gedit text editor, what I said is, here my contents are starting from internal field. So I need to replace it from internal field. Please do not replace the dimension. If you do that, it will create an error. So right from my internal field, I will select everything. I will delete it. And now I will paste the new content. So if you see now, what we have is, we have the boundary condition for the inlet as 0 gradient, boundary condition for the outlet as fixed value 0, and boundary condition for the wall as 0 gradient. So our P file is now ready. After this, remember, save it. Save the P file. So your P file has been updated. Close it. Now I'm going to my terminal again. After finishing my P file, I need to edit my U file. So I'll type the same command, but with gedit 0/U. That means I need to open the U file, which is available in my 0 folder. Once I do that, it will open the U file. Now, if you see in this case, we have again the old initial and boundary conditions. I will go to the downloads folder again. Yes. So again, we have given you one more file, right? That is the velocity file. If you open that, these are the boundary conditions for velocity. Again, copy it, copy the whole thing. Now, if you compare with the velocity files, everything from boundary field has been given. That means dimensions and internal field you don't need to change. So leave the dimensions and internal field intact. Delete everything from boundary field. I'll wait over here. Wait for a moment so that everybody is up to pace.
One question,
I-
sir.
Yes.
Do we have to give boundary condition for pressure and velocity at all the boundaries?
Yes, you need to give boundary condition at all the boundaries.
Like for both pressure and velocity also. Like generally we give for
Yeah.
one only.
Yes, no. See, so in OpenFOAM, you have to give boundary conditions to all, right?
Okay.
I think in ANSYS or everything, it gets automatically taken.
Okay. Okay.
Okay, it may be internally doing it, but in OpenFOAM, we have to specifically specify.
Okay.
Okay. So now this copied content we need to paste over here. So as I said, in our U file, we have everything from boundary. So you have to delete all the contents from boundary. Please don't delete the internal field and dimensions. So I'll delete that, paste the new content, and I will save it. Once I do that, I can close the U file as well. Okay, let me minimize this. I'm going back to my terminal. So we have finished changing the P file as well as the U file. Now what we need to do? As I'll have that structure over here. See, inside, now we have finished all the contents of our 0 folder, okay? In pipe, there was 0 folder. All the contents of our 0 folder we have edited. We have edited the P file as well as the U file. Now we'll go to a constant folder. In a constant folder, this polymesh is there because we have meshed. So it will have all the mesh details. So this we don't need to worry about. We need to edit the transport properties. That is, we need to specify what is the viscosity. So to edit that, I can open it here, but I will show you how to open it from the terminal. Now my transport properties is in the constant folder. So to open that, the command will be gedit space constant / and then transport properties. So again, a trick over here for people who are very new to Linux is that once I start to type the command, I can press tab and it autofills. And by this, I know that I am doing the correct thing. If it is not autofilling, that means I might have not entered something correctly, or I might be in the wrong location. And then I'll try transport. So I start, and if I just press tab, it auto completes it for me. Okay. Now, if I press enter, it will open the transport properties file. So here, our viscosity is specified. Now, for our case, the viscosity that is given is 1e minus 6. We need to change this to 1e minus 6. So I'm deleting it. So my viscosity, that is Nu value, I'm changing it, and it has to be 1e minus 6. Once I do that, I will save this. So remember, you have to change the viscosity. If you forget, then the results may be slightly different because it will be for the viscosity that was there previously. So has everybody done this? Open the viscosity file and change the viscosity from 0.01 to 1e minus 6. I'll repeat this again. I'll close this. So to open it, you have to type the command gedit space constant / transport properties, and then enter. It opens the transport properties file in your gedit text editor. There in your Nu, you would have had the value 0.01. Delete that value 0.01 and replace it with 1e minus 6. That means you are changing the property. Once you do that, save. Yes.
Sir, I'm not able to open the transport properties to gedit
Okay.
command.
So what are you typing? Are you typing gedit space constant?
Yes, sir.
So where are you? In which directory are you currently in?
In 0.
Okay, correct. So now you are in 0 folder.
Yes.
Okay. So you are trying to search in 0 folder for a folder named constant.
Okay.
So you understood what is the problem?
Okay, so I have to get out of 0.
So to come out of 0, so I will go to 0. Okay, now you are in 0 folder. So in 0 folder only P and U file are there. To come out, you
Yes.
need to press the command cd space dot dot. That means it will come down or come up one directory, whatever it is. When you do that, it moves out of 0 and comes to pipe. Okay, now if I do ls, in pipe I have 0 constant and system folders. Now that
Yes.
command gedit, this command will work for you now. Gedit constant / transport properties.
Yes,
So
sir. It okay.
while you all are doing this, for the people who are new, also try to understand what those commands mean. When I'm saying that, so that you will be able to understand why it is not working. I know initially
Yes,
it is
sir.
very difficult what is happening, what is the CD 0. But when we are saying, try to also understand. It is just navigating. You are just going from one folder to the other. Once you get used to this, you will say, this is much better, the terminal. So it only takes some initial, what you can say, initially some resistance is there for us to, it feels so difficult. Then it becomes very easy. So once you do that, you edit the transport properties, change the NU value from 0.01 to 1e minus 6. I'll again open that. Over here, you might have had 0.01, change it to 1e minus 6. Now, once you do that, save it and close it. 1e minus 6 and save it and then close it. So now we have edited the NU file as well. Now if I go back, what is the next file? The next file in my my pipe file is system. In system, there is block mesh dict, control dict, FV schemes, and FV solution. So FV schemes and FV solution, we don't need to change. Whatever the schemes and solution methodology are there, they will work for this simulation. So we are not going to change them. Block mesh dict we have already edited in our first tutorial. So now what we need to change is a control dict. So to do that, I can do, see if I do ls, I have 0 constant and system. Now my control dict is in the control dict is in which folder? It is in system folder. So I will type gedit space system / control dict. So if you see, I am not typing the whole thing. I'm just starting. I'm pressing tab, so it auto completes. In system, I need to open control dict. So everybody open that. So this is it. So this we need to change. Now in control dict, to change that, we have already downloaded those files, right? So if you go over there, there is a control file as well. So you open the control file, copy all the contents. This is the file that you have downloaded. In your downloads, there will be one pressure file, one velocity file, and one control file. So pressure and velocity we have already done. Now do the control file. Copy everything, copy all the contents of the control file. Now let's go back to our. Okay, so now I need to delete the contents, this content. So right, in my file over here, in my text file, I'll just tile it side by side. So this is one, control it over here is one. So I have everything from application. So I need to delete everything from application. So from application, that is line 17 for me, all the way up to runtime modifiable. This comment also, because I copied everything, so I'll delete the whole thing. Okay. After deleting the whole thing, I need to copy this and paste it over here and save it. I don't need this anymore. After I save it, I'm closing it. So right now, what I've done is I have replaced the contents with the I have replaced the contents of the control dict file. So I will again show you what I did. Sorry. So in this control dict, I have edited, I've copied whatever the previous contents and saved it over here. Just to give a quick overview, we'll be using the application icofoam. We'll start at 0 time, end at 5 seconds. The delta t that we are using is 1e minus 2. That is the time step that we are using is that. And the rest of the things are when we are going to write it. We are going to write it after every 100 time steps. This write control means we are going to write it at time steps and every 100 time steps. Purge write to, when we do this, it will save only the last 2 files. Because when we are running the simulation, if you see what we did yesterday, this purge write we had not included. So it was saving all those files. Now in the simulation, if you don't need so many files, if you're only interested in if your main interest is only at the steady state solution, you don't need the how the flow profile is developing. So that time you don't need to save so many data files and waste that much of space. So that time you can give something called as purge write. So it will only save the last 2 files. And then rest is whatever is the write format. So this is the contents of our control deck. So I hope everybody has copied this. Now, once you do that, you are now ready to run the simulation. So remember, we have already done block mesh. So we don't need to do block mesh again. We can just do icofoam to run the command. That means we have finished meshing. Now we are just running the case. To run the case, we'll type the command icofoam. Remember, ICO and F is capital. Over here, if you see everywhere, whenever we are moving from one name to the other, the first letter of that next word is always capital. So that helps us to identify. So this is the nomenclature that is used. So type icofoam and press enter. Okay. Okay, now I think I need to mesh it again. What I'll do is I'll clear this. Now the command that you can do to clear it is foam clean case. So this command we have not taught you, but you can run this command foam clean and case. So as I've said, first letter is always small. The next letter of each word is capital. So foam clean case. When I run that, it cleans the case. Now I need to run block mesh again. So I'm running block mesh. Okay, then I'm running the command icofoam. That is, I have meshed it and then I'm running the icofoam command as well. So it is solving. It will take some time. It will take some 1 to 2 minutes for us to run, I hope. In the meantime, you can take a short break when it is running. For those who are having any problem, you can ask us in the chat. We will help you.
So one question, because we are purging the files, does it get saved for post-processing, like the figures and all?
Yeah, when you are purging, you saw the purge write was 2, I think. So
Yes.
only the last 2 files get saved. So you have to use purge write only if you don't want to save all those data, right? Sometimes you are only interested in the final simulation, the steady state result. And that is what you're going to present to somebody. That is what you're going to use for analysis. Then you don't need to save that. So that time you can give some purge write and maybe save only 2 or 3 files last. But if your interest is in studying what is the transient behavior, like how my flow is developing, how my heat transfer is happening, and you want to see the transient behavior, then you need to save those files at a particular instance so that those files are available for post-processing. And that is the choice that you have to make depending upon, what is the time scale of your problem, what is the time scale that you want to be resolved, like you want data after every 0.1 second, or you want data after every 0.01 second. So all those things that will depend upon, that will change from problem to problem. Okay, so now this is done. Once the simulation is done, so the spoken tutorials are designed so that you can rewind them, go back. So I think all this, whatever I am doing or I am demonstrating, is from the spoken tutorials itself. So with whatever idea that you have now, little bit, if you go to spoken tutorial and do it one by one, it will be very helpful to you. That is why the spoken tutorials are designed. Yes, is there any criteria to define the end time? Okay. Yeah, so generally, say in heat transfer problem, you have to identify what is the time scale, right? How much time how much time will it take for steady state? In flow, one way to do that will be to understand how much, like we have given an inlet velocity and we have given a length. So how long will it take to what you can say for the flow to reach the end? Say it takes L by what is your speed? Speed is distance upon time. So time will be distance upon speed. So if you do L by the length of your domain divided by the velocity that you are imposing, you get an idea of the time scale, at how much time it takes. Now after that, what you can do is give at least one or two multiples of that, so that by that time the flow is developed. So the bare minimum will be one times what you can say, that time scale that I told you, 1. But that is not ideal. You have to give at least 2 to 3 times that value, so that you get some good results. And also, I think in the later on tutorials, we will teach you that, right? We will teach you things like how to monitor the transient behavior. We are also coming up with certain tutorials. I think it's on day 3 or day 4, wherein you will have to monitor certain parameters with time. So as soon as those parameters, say like in this case the average velocity, if the average velocity is constant over time, that means you have reached a steady state solution. So that is one way of doing that. So we don't have to guess. We will calculate the average velocity, and that will happen. But that we will show you in day 3 or day 4. Don't worry, you will learn a lot of things. Yeah. I hope everybody has done this simulation.
Hello.
Yes.
Sir, can you explain once again to change 0 to 0 ORIG file?
Yes.
What is the purpose for that?
Okay. So see what happens
Sir,
is okay.
no demonstration, just explain what is the purpose of
Okay.
0
Okay.
to 0 ORIG file.
Okay. So what I'm trying to say is, when your file structure, right? I open some file structure. So your general file structure for, say, your same pipe. My general file structure will be, there will be a 0 folder, constant folder, and system folder. These 4 and 5 have been generated during runtime. So these are result files. So don't worry about them now. So initially you have a 0 folder, constant, and system. When you start off, right, when you start off any simulation, first thing that you will do is mesh. Okay, and only if your mesh is absolutely correct, you are getting everything correct, then you will go into setting up boundary conditions, defining them, the patch, and everything. So when you are doing that, you are not interested in the 0 folder, right? But you will say, sir, if it is there, what is the problem? Let it be there, right? But when you do the mesh and you want to visualize the mesh using Parafoam, the ParaView by default it opens the 0 folder to check, what are the values, and it loads those values. And now what it will see is, in 0 folder you have defined, say, one patch called as moving wall, which was there in cavity, but that moving wall is not there in your block mesh because you have already changed, and you have not changed the 0 folder. And you haven't changed that 0 folder because right now you are not interested in that. You are only interested in the mesh at the moment. So to avoid ParaView using that 0 folder, what we do is we rename 0 to 0.oric. So ParaView does not see the 0 folder, and it will show you only the mesh, and that error is removed. Now, once you have your mesh completely ready, everything is done. That means your inlet, patch, wall, everything is coming properly. You are ready. Now you have to go to simulation. Now you have to specify the boundary conditions. So the next step will be this 0.oric folder, which we had renamed, you rename it back to 0, so that gets used in the simulation. So you rename the 0.oric to 0, and then provide the appropriate boundary conditions for every patch. Because if you wouldn't have done that previously, then Parafoam would not have worked. Block mesh works without any problem. It meshes because it does not need the 0 folder. But ParaView, during visualization, it automatically checks for the 0 folder. So that is the issue. I hope I was able to answer your query.
Yes, sir. Okay. Thank you,
Sir, I have a question in that the same one, that you are telling in place of 0, you are putting that 0.oric. In place of
Yes.
0.oric, I will put any other names, because that will not also give the because
Yes,
it is searching 0.
correct, correct,
I
correct.
can
That
put
is
any
that
other
is just
name.
a yes, that is just a convention that it is being followed throughout in open form, right? That is just a convention. .org means something like it's the original file. This 0.org
Okay.
naming nomenclature. See, like when you're coding, right? People will say use the keyword flag. When flag becomes 1 or when flag becomes 0, it will specify something. I don't know if you have done some coding, you will know that, right? There are when you
Yes.
want to there is a flag word. Now instead of flag, you can use anything, right? You can use
Right.
j equal to 1 or j not equal to 1. But so that everybody else, like if you give this case file to somebody else, they will also know the nomenclature. So some standard nomenclature that we follow is we rename the folder to .org. So that is just a nomenclature. It will work whatever you want to name it.
Okay. Okay.
So I hope everybody has done this. What I'll do is I'll share the tutorial files for the next case so that you will be able to do the post processing. I have shared the new spoken tutorial that you have to follow. This is for basic post processing. Now you are ready. Everything is there. You can watch this video and try for yourself. Okay. I think it will be better that you do this session with the video and I will demonstrate after maybe 15-20 minutes, because you can go back, you can re-look at that video and do that multiple times, because there are a lot of clicks that you need to do, apply this and that. So a video will be very helpful in this case rather than live demonstration. So you do go through that video. We'll hold on for like 10-15 minutes so that you all are doing it. And if you have any problem, we will be here to help you. Maybe after that, I will demonstrate it once. Maybe it will take 5 minutes for me to demonstrate that. Okay. So you all please go ahead and do that. I will share the YouTube link as well. I have shared the what you can say, the tutorial, the next tutorial that you have to follow, the spoken tutorial as well as the YouTube video. Whichever works for you, you follow that. Yes, yes, Nikita, please go ahead.
Sir, MB 0.00.org is not working in my laptop.
It should work. You have to be in the right folder. Can you just check? Maybe you log in. Viraj, can you? You just share the screenshot, or because you might be in the wrong folder. See, when you
Okay,
have
sir.
to do that command will work only. Like say if I do ls, right? I have 0 folder, right? So for doing that command, okay, I'm sorry, I'm not sharing my screen. I'll share my screen. So right now I am in my pipe folder. So in the pipe folder there is 0, constant and system. So that mv command, right? mv 0 to 0.org will work now. Okay, see, because it sees that there is a 0 folder in my thing. Now if I do ls, you see that 0 has been renamed to 0.org. So this command will work only if you are in the right directory. Now I will change the directory. Say I go into, say, constant directory. Now I'm in constant. If you see, my location is I am in run, pipe and constant. Can you see this?
Yes, sir.
So now if I run that command, okay, 0.org, it will give me error saying that no such file or directory. Because
Okay, sir.
in constant there is no 0 folder. So you are trying to change 0 folder to 0.org in constant. So you have to make sure that you are in the current directory. If you are in run directory, you have to go to pipe. And
Okay.
to move between directories, you need to use the cd command. Okay, cd is change directory. If I have to go out of this constant, I will press dot dot. So see, from constant I have come down to pipe. If I do
Okay,
cd
sir.
space dot dot, I have come down to run. Now, if you are in the run directory and if you are trying to run this command, then also it will give you an error. So you need to be in your case file that is in the pipe directory. So from run to go to pipe, you have to do cd space and then pipe. And now you can run that command again. So now I will rename it back, because I don't want that to be a problem. Not org to 0. And now if you see ls, it worked for me. My 0 is again renamed to.
And
Yes.
sir, if I'm using the 0, then
Anything, right? What this command means?
okay.
This command only means that you have to rename 0.org folder to 0 or 0 to 0.org folder. But for that, your 0 folder should be in the directory in which you are there right now.
Okay, sir.
Okay, it should be immediately in the directory that you are there inside now. It cannot be that it is in some other folder and then some other folder. If that is the case, then you have to give the full path of that.
Okay, sir.
Like I will demonstrate. Say I am in cd dot dot. I am in run. Now my 0 folder is in pipe. So if I have to run this mv command, I cannot write 0 to 0.org. See, again it will give an error because it is saying no such directory. But instead of that, if I do mv space what is that? Pipe slash 0 to 0 to 0 dot org. I hope it works, or I need to have pipe here also. Just let me check once. Okay, see that is a mistake. So in this, while specifying, I need to specify the path for the destination also. I need to write pipe slash. So what I'm saying, I am not in the pipe folder. So rename the 0 folder in pipe to 0.4 org folder and save it in pipe itself. So this command will work. Okay, pipe because I've already renamed it. Okay, I think best is to go to that specific file. Where is that? CD5 and then run that command. Yes. Yeah, okay, I think what happened is when I did mv, it just removed that folder. You follow that, just follow that, go to that. I will resolve this now. Make sure you are in the correct directory. So now the others, just give me one moment. I want to demonstrate something wherein people are still having a problem. I'm doing it over here the Windows way, renaming it to 0. This also works. Now, okay. Now for some of you, the problem is that for you, the ParaView is installed natively on Windows, right? Because you are having some problem. So after your simulation is done, you need to type touch, touch touch space, maybe result. This is a file name that you're giving, result.foam, anything. You can give any name and then press enter. So what happens? A touch result.foam file gets created. So if you want to view that, just see ls. You see there is a result.foam file that is created. Now, if you have to open this, what you need to do is first do explorer.exe and space and then dot. What this does is it opens the current directory in your file browser. That is this. So it opens this. If you see there is a result.foam file that is created. Now you have to open this with ParaView. So for doing that, you have to right click on that and then select open with and then search for the application by doing choose an application on your PC. This you have to do only once. Once you associate .foam file with ParaView, then it will not give you an error. For me, it will not work now because I have not installed ParaView natively on Windows because my ParaView is working. But these are the steps that you need to do. So please do this and do the post processing.
Okay, sir.
Excuse me, sir.
Yes.
Sir, how to install ParaView using Linux command? Is it means a sudo apt install ParaView or something?
Yeah. So Mr. Prabhu, when you install OpenFOAM, right, the way that we have told you, then ParaView will get installed with it directly. It will be bundled along with OpenFOAM. ParaView will also be installed. If that ParaView is not working for you, then we have told that you need to download and install it separately. But if you have some problem, you can write in the chat. Somebody will assist you. We were hoping that till now all the problems will be resolved. Like nobody has any installation problem. But if you still have a problem, write in the chat. We have a team. Somebody will guide you with the installation problem.
Okay, sir. When downloading version 9, that ParaView is within that only.
Yes, it
But
gets downloaded automatically. Even for version 7, it's not like that. Any OpenFOAM version, if you download, ParaView gets downloaded with that.
okay, when I'm typing that paraform, it's not opening. That means there's some error occurring there.
Yeah, so please write in the chat, and maybe one of our TAs, they will give you a meeting link, and you can share your screen and show your problem to them. It may be some
Okay.
small problem. We'll rectify that.
Okay.
Okay. Hello?
Yeah, sir, I am getting a fatal error in which it is saying cannot find patch field entry for inlet.
Did your simulation work?
Simulation is not running.
Simulation is not running. That means you might have not. So there were certain steps, right? You have to copy the P file, replace the P file, replace the U file, change
That I have done. That I have done.
Then if it is saying patch field, then
At the end of
clear it once.
Okay.
Clear. Run the command foam clean case. Okay, do one thing. Write in the chat. Somebody will assist you. I think you might have missed something. So the best thing will be foam clean case, do block mesh, and run the icofoam again. If still you are getting this problem, that means something is remaining in your replacing.
Yeah.
You might have missed something. That's why it is saying patch field entry is not found. Because you might have defined inlet in one, right? If inlet might be there in block mesh, but in your P and U file, inlet might not be defined. So that's sort of an error you might get.
Okay.
Oh, okay.
Sir, I have followed the tutorial.
Yes.
And I have saved the images, screenshots. I'm struggling to find where it got saved, sir. Can you help me in that?
Okay, so while saving, try saving again. Okay. So this is my simulation result, right? I can go and look at the U profile, but I will not see anything because I have not created a slice. Okay, if I create a slice and I create a slice, say on the
I'm not talking about splice, sir. I'm talking about saving.
Yes, so before saving, I need to maybe generate something data. That's why I'm generating a data to save. Okay.
Okay.
Okay, now if I go to the last time step, see, I'm getting some result. If I want to save this, I will do file, save screenshot. Now, if you do that, once you do this, you see this dialog box, right? It shows you where you are saving it. You are saving it in home, in your OpenFOAM folder, and then in the pipe folder. If you don't want to save it over there, you can maybe go up and navigate. Okay, I say I want to save it over here, or I want to save it in my pipe folder. Things like that. So those things are here from here you have to select. So do this again, and maybe you will be able to do it. Okay. Please, can you tell me what is the plus? Everyone, can you all tell me what is your status? Have you finished the spoken tutorial last one, wherein you have analyzed the simulation results using ParaView? Has everyone been able to do that? If you can just maybe type yes in the chat, so that I know what is the status. Only a few yes. Okay, some people are still trying. So I'll wait for another 5 minutes. Then I will also demonstrate it once so that I can recap it for you. I hope now everybody has done this. So maybe I'll share and maybe demonstrate it once again. So our simulation is done. Now I will open the Parafoam utility. Our simulation will open over here. So if you see, I can click on apply and I can get all the results. Now, in my result, if I want to color my geometry based on the what you can say, the values, then what I can do is I can look at only the internal mesh. I can look at outlet, inlet separately also. Let's say if I want to look at only the internal mesh, I am checking only the internal mesh in the mesh parts. So all those things are available in your properties tab. If you scroll down, mesh parts. So I can check the whole thing, uncheck. I can select only internal mesh. I can select only inlet, outlet to view my results at a specific location. So let's say now I want to see the velocity. So I select the velocity. and this is my initial time. Okay, my domain, I have to rotate it this way so that it is in line with what was there. This way, yeah, or this way, yeah, this will be better. Now, if I go to the last time step, the flow will develop, but I will not be able to see that because on my wall, I am not able to see that because on my wall, the condition is always what you can say, velocity is 0. So you'll see velocity is 0 throughout. So how to view what is inside? So to view what is inside, we will add something called as a slice or a clip. I can clip. So this, my clipping plane is, yeah, this. I can clip along y normal and apply. So what it will do is it will clip it. Let me just invert it. If I invert it see, it initially had clipped the other side and I wanted to see what is there on my side. So I will click on invert. So it shows the velocity profile. Now, if I uncheck this show plane, then all of this, whatever had come, that will go. Now let's see how it looks. Yes. And rotate it by 90 degrees. This is what I'm doing by this plus X, Y, Z. So I have to get a better view. So if you see the flow, it is coming with certain velocity and the flow is developing as it is going inside. So you see the center line velocity is increasing and the flow is getting developed. So this is one way of visualizing. Okay. That is clip. Then you can add something called as streamlines. You can add something called as glyph. That also you can do. So to do that, I will delete this clip. Okay, and I will add stream tracer. Now, the source that we are selecting is we are selecting a sphere. Now it will give me all the streamlines through this particular sphere for U. And if I apply that, so you see I'm getting only 2 or 3 streamlines. Where is that? Just hold on. I can hide my sphere. I'm getting only a few points. If I increase this to maybe say 1000 points, and then apply, I will get many more streamlines. So this will show me how my flow is going in the domain, the streamlines. This is one way of visualizing. The other important one is called glyph. So in glyph, what we'll do is we'll add vectors. So when I click on glyph, I need to give an glyph type is arrow, my orientation array, like what should be the direction? Direction should be in the direction of U velocity, and scale. I can scale it with U velocity. That means vectors that are longer, vectors which having high magnitude will be longer, vectors having low magnitude will be shorter. And I can do that. I can click on apply. I will hide the pipe because with this pipe checked, I'm unable to see what is happening inside. So here, this is the glyph that you have created, and this is the pipe. So you can hide the pipe by clicking on the eye. So you are seeing only the glyph. So I can zoom in. So this is the velocity vector. So internally, the velocities which are at the center are having larger magnitude, so they are longer in length. Then at the walls, the velocity decreases, so those vectors are smaller in length. That is what we are observing. See, if I rotate it, maybe if I zoom in. So we see this profile. The vectors at the center are longer, vectors at the wall are shorter. This is something that we are seeing. This can be done by the glyph function. Now, what else is there? Yeah, we can do something called as plot over line. So for that, I will first delete the glyph. Yeah, okay. I'm doing a little slowly now because everybody has done. So I was just maybe kind of demonstrating. So you can do plot over line if you want to visualize, like if you want to visualize how the velocity is varying along the radial direction. So what I will do, I will click on plot over line. Now in my radial direction is along either y or x. So I can just click on y-axis. Okay, automatically if you see, if I zoom in, a line along the y-axis has been taken. I can just click on apply. If I click on x-axis, it will be taken along x-axis. If I click on y-axis, it will be taken along y-axis. If I click on z-axis, it will pass through the center. So if you see, it is passing through the axis this way. So currently we'll take it, say, along the y-axis, and if I click apply, I am getting a profile. So what it is saying that velocities at the wall are 0 and at the center they are increasing. So you can extract this data and you can compare it with the analytical solutions that you have in your literature, in the books. How to extract this? So you can extract this by doing file and then save data. When you do that, some people are asking, I'll just refresh that again. So it will say where I need to save that data. So you can give the location exactly by browsing. This is same as Windows, right? You give the location where you want to save, give a file name. Say this is my velocity profile. So I will type velocity profile. And then this will be saved as a CSV file. So CSV is comma CSV, comma separated values. So this is the format that I'm selecting. Once I do that, and instead of saving in the run, I'll go up. In the pipe, I will save it in the run folder. Okay. Then it is asking for precision, how many number of decimals that you can change. Now I'm keeping it 5. Click OK. Now let me go to my pipe and run. So in this run, if you see, this velocity profile Excel sheet has been created. So this will have data of all the points, right? For various points. So what does U0, U1, U2 signify? U0, U1, U2 is nothing but your X, Y, and Z components, because your velocity will have a X component, Y component, and a Z component. If you see, your X and Y components will be almost 0, because X and Y components are in the radial direction. So your radial flow will be close to 0. You will have only axial flow in this case. So that's why your velocity is only varying in the Z direction, if you see, for all the points. So your X and Y velocity will all be close to 0. Only your Z velocity will be changing. Then that is your X, Y, Z component of velocity. Then there is a pressure for those specific points. Then there is something called as arc length. Arc length means it is we have extracted data along the radial direction from the center point. So from that point till the end, what is my arc length? So if it will start with 0, this corresponds to my central point. And if I go down, if I go to the last, and okay, I'll click something. 1 minute. Okay, and my last is 0.01. Okay, that is my last length, 0.01. So this is in the radial direction, starting from 0 to 0.01 at the wall. Now, next what we have is, we have the points. This is nothing but the X, Y, and Z location of the point. So if you see, your X and Z will not change because we have plotted along Y, so only Y will change. So Y will change from something like this 0 to 0.005. Okay, now next, you want to save this. You can also save screenshots. Like if you want to extract that data and save screenshots, instead of saving this, you can save screenshots. So now I am in the plot over line view. So if I save the screenshot, it will save screenshot of this plot over line. If I want that screenshot, I can save it by same method. Or if I want the screenshot of this, that is what is the colored image, I don't need this, I will delete this. And this I can save. But okay, now saving this is of no use because we are not seeing anything. So first what we will do is delete this plot over line. I will show you how to create a clip. A clip we had already seen. Okay, I will create a slice. Say I create a slice along the Z normal and I click apply. Okay. Now, as sir had said, right, let's try to create that warp. So that is, okay, where is that option? Yeah. Yeah, that is warp by vector. So when I click on warp by vector, it is asking me to scale it. So I don't want such a big I will scale it by a factor of 0.1, and I click on apply. So if you see, it has scaled those velocity. I could have directly scaled by U or keep a scale factor 1, it will be larger. Now the coloring scheme for this is based on the U velocity. So you see, this is how your velocity profile will look.
Can you repeat this?
Yeah, okay, I will repeat this. I will delete this warp. Okay. So first thing that you need to do is create a slice. So slice will be this fourth option. I think first is calculator, contour, clip, and slice. You click on slice, and then I want a slice in the Z normal direction. So I will click on Z normal over here. Once I do that, this gets created, and then click on apply. So if you see, I'm just seeing a 2D structure, right, with the different colors. Now this you want to warp. So the warp function is there over here, this one, warp by vector. Okay, when you do that, that means it will warp this plane based on what is the vector magnitude. Okay. If I keep scale as 1, and if I do that, it will become very large based on the velocity. So we are scaling it to something like, say, 0.1. I don't want to extend it too much. Okay, I just want to visualize the change. So I'm scaling it by a factor of 0.1, and I'm clicking apply. So you see, it has scaled this, and this is something that I can see now after pressing apply. Now, this is the what you can say, the paraboloid shape that somebody was rightly guessed, right? So now, if you want to see this with respect to your pipe, then I should check my pipe as well. So I'm checking my pipe. But the problem is, as soon as I check my pipe, the internal structure is not visible. So to do that, what we can do is we can rectify that by reducing the opacity of my pipe. So I have clicked on pipe, and if I scroll down in the properties tab, there is something called as opacity. I can reduce that opacity to maybe say 0.2 or something like that. And you see, I will start to see that warp. Okay. If I can reduce this further depending upon what you want. So this is how it looks inside the pipe. So this is something also that you can do. And if you want to save this view, you want to adjust it the way you want, and then just do file, save screenshot. It will save screenshot of this view, and give the location, file name, and file type is PNG. So if you do this, you will be able to. So I think we have mostly covered everything. Auto line, warp, glyph. The video is there for you to refer. You can practice that. The thing is, ParaView has lot more functionality than what we can demonstrate, and that lot more than what we ourselves have tried. So it is all on your usage. If you are using it more, you will be able to learn much more functionalities than what is available. And there are many tutorials available online also. You can do that and explore it. But we have told you what are the basic ones that are needed for you to at least be able to visualize.
Sir, one question. In the tutorial, we have calculated the value for pressure and compared it with the numerical result.
Yes.
Can you show me how you did that?
Okay. In the spoken tutorial, you mean?
Yes, the calculated value was 2 points and the numerical value 2. How to get that numerical value here in this tutorial?
Okay. So was that at the outlet? Can you just tell me if that was at the outlet?
It was at the inlet.
Okay, it was at the inlet because outlet is 0. Correct. So what you can do is, the same thing. What we had done, we had plotted over the line at the center. So what I'll do is I'll delete all this. I'll delete this slice as well. Maybe increase the opacity back. Now I want to know what is the value at the inlet. There are multiple ways of doing that. I can just maybe uncheck internal mesh and check only the inlet patch and apply. So I get data of the inlet patch only, right? Now inlet velocity is 0. So as you can see the velocity, sorry, no, is this my inlet patch? Yeah, correct. I have not yet. Okay, this coloring is pressure. Okay, the value is very low. It is not 0. The value is very low. The color scheme is such that I am feeling that the value is 0. Yeah. So what you can do is you can select P over here, pressure, and you get all the pressure values. But what you can also do is you can plot over the line over here. So if I create plot over line, it is generating a plot over this line. Okay, and I can extract this data. If I click apply, I am getting the p value and the u value, and I can export this data.
Okay. So the single value we have used in the tutorial is the average of this whole phase.
Yeah, you can do an average of this phase. How to do an average, that is also a possibility. Or you can get, once you extract this data in your post processing, you can average it out.
Okay.
Okay. So exporting is pretty simple. You can do file, save data, and export this as CSV. And if you don't want the U data also with it, then you can just uncheck the U value and you can only get the pressure value. Or you want the view value also with it. So those values. So you can get that value and then average it.
Okay,
in the further tutorials, we will also teach you how to do the averaging over here itself. Okay, based on I think volume average. That is what we are going to teach you. Actually, this has a lot more functionality. There is a calculator function which you can do many things you can do inbuilt, or you can extract the data and you yourself can then later on post process with whatever your Python code, or it depends. So I think.
Hello.
Yes.
If I want the circumferential value of the property, then how can I get it?
By circumference.
Around the circumference. Along the circumference, I want the value of wall shear stress, for example. For this instance, maybe pressure, if, for example, if I have to get the along the
shear stress.
It is
wall
not there here
stress,
anyway.
I think you will have to calculate
pressure,
that, right?
Take pressure, for example, here.
Yes. Yeah.
So pressure along the circumference with respect to angle. Can I get it?
With respect to angle.
Yeah. So along the circumference, I just need a value of pressure along the circumference.
Okay, for circumference, I can try something, but I'm not sure whether exactly it will work. We can try looking at it at the walls and then extract that data, maybe. That is one possibility.
Along the walls itself, it is.
Yes.
Yeah.
So if I do it at the wall, okay, and I can see only the wall data, right? And then if I extract this, you will get all the values for the different wall at different locations.
Yes.
Okay, this is possible. But this, whatever you are saying, right?
I need the data along certain circle, for example.
Yeah. So then maybe you can clip it.
Okay, clip it and then.
You can clip or create a slice. See, if I create a slice along, say, Z normal, and if I do that.
But along the wall, it will be the wall shear. For example, in case of wall shear stress, it won't be giving a value. It will be the internal of the internal thing.
Correct. So for that,
how can I?
What I was trying to say is that this will give you the value at the circumference.
Yeah, I got it.
So at one point. Now, if you need that, then this in this slice, in the pipe, I will not only uncheck the wall, I will also check the internal mesh and I will apply.
Yes.
Right? So now if I hide the pipe, so I will get all the internal values as well. Now you will have to compute it. You will have to compute it yourself. Or there may
wall
be
shear stress, for example, is computed, and I have all the values of wall shear stress along this plane, for example, but I need only the circumference, and that too in the order. Can I get it?
That we have not tried. That you will have to explore, because there are multiple things that you can do in this, right?
Yeah, but is there a possible?
No. Yeah,
you got it right.
Yes,
you got it right. I want the wall shear stress along the circumference in right order. It should not be like some random order, like at this place it is this, because in if you just extract the data, it will be like in a random order, right? The order that OpenFOAM decides or Paraform decides. Right?
Yes.
So I need the data in the order of the circle, like 0 to 360 degree.
I think you will get with points. No? With points you can identify that.
Yes,
right?
But it is difficult, right? It is, for example, I have a lot of data and for lot of conditions, then I have to always extract for that points. It is difficult. If there is any method, you got it, right?
Yeah, I understood. So it is. I don't know if there is any easier way, but from the data, so you will be able to do that. The only thing is you will have to maybe
get different data.
A lot more.
It will be a lot of work.
Yeah, a
Yeah,
lot of
that is
work.
what I'm doing now. So, but if there is a possibility of having this on in the circle, for
I
example,
understood.
the one you, yeah, that's.
I understood
Then
what
can
you're
we?
saying. We have not,
Yeah.
we ourselves have not come across that now. So that does not mean that there is no functionality like that. We have not
Okay, yeah.
explored that much. With whatever
Yeah,
we
that's
have
what
done.
I wanted to know if there is a.
No,
And
we have not.
can we import this .dat files, .dat.h5 files, like the transient case files, bulk of them into Paraform?
Transient file of what? Of
many transient files, like it is also running a transient file now presently,
yes,
but
yes.
.dat.h5 file, h5 format.
So yeah, I think so. Paraview should have those functionalities because Paraview can also be used to analyze data of other softwares, not only this. And for OpenFOAM, if you want, you can just this is data for the time instance of say 5. If I just click this button, it will give me time instance of 4. So all the time series data is automatically loaded in Paraview. I just have to press the play button.
Yeah, I
right
got
now,
it. But in the similar way, if I have time step data, several time step data in .dat.h5 format,
yeah,
can I load it?
that.h5 file. No, I have
Can
not
I
tried
load
that. I have not tried that. That is ANSYS data, right?
Yes, ANSYS
Is it ANSYS?
CFO.
Yeah. Okay. Yeah. No, I have not tried loading a time sequence. I understand what you mean because in ANSYS, it will write for every instance, and I will be able to load only one file at a time.
Yes.
Correct. Instead of that, you want a way for it to load all the files.
Yes.
Yeah, that even becomes difficult in ANSYS itself at
In
times.
TechPlot also.
Yeah.
It is difficult in TechPlot also.
Yeah. So I have not tried this in Paraview.
I have same kind of problem some time back, and I used to plot the variable I was interested in the for the post processor. So the ANSYS was calculating and plotting that. After the plotting, you can export those results. So you don't need to load all that into the CFD post processor.
Okay. But that is if you are doing it at that instance. If you have saved and you closed, and then later on also, does it open at all times?
No. You have to firstly specify the expression or some kind of a variable during the setting
Before.
up.
Yeah, I understand. So that is a
that
thing
is
that
possible.
sometimes
That is possible. But if there is a data that is not thought of to be run on Paraview, then maybe it is difficult, right? Then the data that we have got is of no use. For that reason.
Yeah. Okay. I think we are getting into a discussion now. I'm sorry that we have not explored that in Paraview as of now, but there may be some other tools because there are a lot of functionalities. I think it's only a matter of what you can explore. Like calculator function and all is there, but I don't know with that how much that will be helpful to you. So I hope now that everybody has done this session and you have got some idea as to how to post process the data. We will take a break now.
Yes. Okay. So thank you so much, John. I hope you had a very useful and interactive session by John Pinto. You might have some doubts while you try to finish the execution. So you can always write to us. We will definitely get back to you, if not now, but after the workshop, after 5 or 5:30 p.m. today, or maybe tomorrow. Whenever our group members are free, we'll get back to you. Okay. Thank you so much.